Hey guys, let's discuss a new round from Google interview loop, and which is called distributed system. Okay, so here in this distributed system round, we will be the question is you have to design Google web crawler. Now what is Google web crawler? See, Google web crawler is an automated program, or you can say bot, okay, that continuously visit websites on the internet to discover and collect web pages for Google search index. Okay, so whenever you type something in Google search, and let's say you have created new website, and so you want, right, that someone, if he search something from Google, your website should show in the result, right? So web crawler, what they do, all the new website or all the updated web pages, okay, they go and collect that information and then put that into the index. Okay, so whenever someone will search about that particular thing, it will show the result. Okay, so this is how. So the web crawler is the main part of that. So now, simple explanation, if you talk about, see, Google web crawler, or called Googlebot, okay, automatically browses billions of web pages by following links from one page to another. It collects page content and send it to Google's index so that pages can appear in Google search. Okay, so for example, let's say you publish a new blog, okay, and then Googlebot visit your website, it read your page and follow any link on it. Okay, and then Google store the page in its search index. When someone searches for the related topic, Google can show your page in the search result. Now what is the functional requirement? So see, the crawler should discover new URL. Okay, if any new URL came, he should discover it. Someone has uploaded new website, let's say, he should discover that. Now crawl web pages, okay, then respect robot.txt. So this is very important. So what is see, I want that Google's web crawler should not visit my these pages, okay, these informations, because those are private and I don't want it to show in Google search. So I will write that page name in robot.txt so that Google will not read those links. Okay, so or those web pages. So see, before crawling a website, check its robot.txt file. Okay, so this is what web crawler does. Before crawling the website, he go to robot.txt and check the files, and avoid crawling pages or directions that the website owner has disallowed. Okay, then detect duplicate. If you find a few duplicate web pages, duplicate content, so why to store them separately, right? Just store once. Now store web page content and support incremental crawling. Okay, incremental crawling means today I have launched one website, tomorrow I'll do some update, okay, in the web page, so only that delta changes it should again take, because the earlier one he has already taken it, right? So not duplicate work. And then feed the search index. Okay, now step 2 is non-functional requirement. So see, crawl billion of pages, okay, and then high availability, fault tolerant, polite crawling. Now what is polite crawling? See, limit the crawling rate and add delays between requests so that website server is not overloaded. Let's say I have one website which has the millions of pages. Okay, now web crawler should not come to my website and then read all the millions of pages. Okay, otherwise my website will be overloaded and it can get crashed or down. Okay, so he will add some delay there, or some rate, that like today he will read only 10,000 pages, tomorrow he will again read 10,000 pages. So this kind of rules would be there. So that is called the polite crawling. Okay, now horizontal scaling, cost efficient and low latency for high priority pages. High priority pages means the website which web pages which generally user go and access, like Wikipedia or something, right? Now software engineer L4, okay, and senior software engineer L5, what they will answer? So I would build a distributed crawler with a URL frontier. Okay, what is URL frontier? URL frontier is a queue that store all the URL waiting to the crawled by the web crawler. Okay, so that URL frontier, those URL will be waiting there, so that web crawler can read them. Now multiple crawler workers, okay, and not single crawler. You can have a multiple crawler workers. Okay, they can work parallelly. And duplicate detection, content storage, and indexing pipeline. Okay, the crawler should respect robot.txt, avoid duplicate downloads, and continuously update the search index. Now high level architecture will be like this. Okay, first you will have a seed URLs. Okay, those seed URLs, it will load into the URL frontier. Okay, and then it will go to schedule service, and then you will have a multiple workers, right? So crawler worker 1, 2, 3, they will work to simultaneously. They will read the information about the web page. Okay, then after that duplicate detection will happen, and content storage, indexing pipeline. After storing the content, it will give it to index search, right? So indexing pipeline and then search index. Okay, so now what is the seed URL? We have seen what is URL frontier, okay, which is the queue where all the URL will wait who are just will get read by the web crawler. But what is seed URL? Seed URL is the initial web page from which the crawler starts. Okay, the crawler first adds these seed URL to URL frontier, then continuously crawl them and discover more URLs. So staff engineer, what he will be saying, at Google scale, I would partition the URL frontier across distributed workers. Use intelligent scheduling based on the page importance and freshness. Okay, intelligent scheduling he will be using. He will read pages which are more important and which are more fresh. Okay, new pages. Implement incremental crawling. Okay, means the delta changes, and integrate AI summarization before indexing, and continuously monitor crawl quality and infrastructure utilization. Now enterprise architecture, so it will be something like this. Seed URL, okay, he will load into the URL frontier, then from there you will it will go to priority scheduler, then multiple worker will work together, and then your robot service which will read the robot.txt, and then duplicate detector and spam detector, they will work. Okay, after that content will get stored. Okay, then it will parse, and will go to AI summarizer which will create the summary. Okay, then it will go to indexer, and it will appear in the search index. Follow-up questions. So now here we will be talking about 14 follow-up questions. Okay, small one. So the first one is URL frontier. So the same thing, right? L4, L5 will say the URL frontier is store URL waiting to be crawled. Use a priority queue to determine crawl order. L6 will say that partition the frontier by host or domain to enable distributed processing while respecting per domain crawl limit. Okay, so like per domain crawl limit means for this particular website, let's say today I will read every day 10,000 pages only. Okay, that's it. So that is per domain crawl limit, and you need to distribute it on the basis of host or domain. Okay, partition the frontier based on the host and domain. Okay, to enable distributed processing. Now follow-up question 2 is duplicate detection. Okay, so generate a hash of page content. If the hash already exists, then skip indexing. So using the hash, he will detect the duplicate. L6 will say that use URL normalization. Okay, we will see what is URL normalization. See, the URL normalization convert different versions of the same URL into the single standard format so that they can be treated as one page, avoiding duplicate crawling. So for example, see https example.com, okay, and then https example.com / and then http example.com in capital and S is not here. Okay, so all these three are the same URL, right? So this is called the URL normalization. Then content hashing. Okay, it will create a hash of a content for the duplicate to know the duplicates. Okay, and then near duplicate detection means sim hash or min hash you can use. Okay, so see, all the normalized to one canonical URL before crawling and indexing. Okay, now what is canonical? So a canonical URL is the official standardized version of a web page used to avoid duplicate crawling and indexing. Now follow-up question 3 is related to robot.txt handling. We have already seen this, right? So L4, L5 will say download the cache robot.txt before crawling a domain and skip disallowed URLs, right? Now L6 will say cache robot.txt with expiration and refresh periodically to avoid repeated downloads while honoring updates. So here honoring updates means respecting any changes made in the robot.txt file. Follow 4 is related to scheduling strategy. So L4, L5 will prioritize. First thing is frequently updated pages, right? Because the old one you have already read it. So frequently updated page you will read. Then high authority website. What is high authority website? Trusted and reputed website that provides reliable high quality information like wikipedia.org. Then newly discovered pages. L6 will say about the scheduling strategy is he will schedule it based on some factors. Now what are those scheduling factors? See, these are factors a web crawler scheduler uses to decide which page should be crawled next. So there are few factors like page rank or importance. Okay, second is change frequency, then crawl history, after that domain politeness, crawl budget, and user demand. Okay, now let's see what these things are. So the first one is page rank or importance. So crawl more important and trustworthy pages first. Okay, so for example, crawl wikipedia.org before a small personal blog. Change frequency means pages that changes frequently are crawled more often, right? So for example, a news website is crawled every few minutes, while the company's about us page may be crawled once in a month, right? And then crawl history. So use previous crawl data to decide when to revisit the page. Okay, so if the page rarely change, crawl is less often. If it is changes every day, then revisit it daily, right? Then domain politeness. So avoid sending too many requests to the same website in a short time. So for example, after crawling one page from example.com, wait for a few seconds before requesting another page from the same domain. Now crawl budget. So each website gets a limited number of pages crawled within a given time to avoid wasting resources. Okay, so for example, crawl only 10,000 most important pages of a website today instead of all 5 million pages. Okay, next we will read after some day or next day. Then user demand. So pages that users search for frequently are crawled more often to keep search result fresh. Okay, for example, during the Cricket World Cup, sports news pages are crawled much more frequently because many users are searching for them, right? Now distributed crawler. Follow-up question 5 is related to distributed crawler. So L4 and L5 will say that run multiple crawler workers in parallel. Okay, L6 will say partition URL by domain hash. So each URL is hashed using the domain like google.com and assigned to a specific worker. This ensures that all the URL from the same domain are proposed by the same worker. So this is what we have seen, right? That you partition it based on the domain name, okay, or the URL, so that worker will take the worker will work on the same kind of pages from the same domain. Okay, then preventing multiple workers from crawling the same website simultaneously and avoiding necessary load or duplicate work. Now follow-up question 6 is related to load balancing. Okay, so L4, L5 will say distribute URL evenly among crawler workers. Okay, and L6 will say that use dynamic work stealing, so idle worker can process pending URL from busy worker. So let's say you have 10 workers and first, second, third worker has completed their task earlier. Okay, so they can steal the work from other workers. Okay, and then continue doing the work. Okay, follow-up question 7 is fault tolerance. Okay, so L4, L5 will say persist crawl state, so failed workers can resume. So we will persist the state of the crawler so that if they failed, next worker will take the task and then they can resume from till those people have completed the job. Now L6 will implement persistent queue. Okay, persistent queue, then worker heartbeat, automatic retries, checkpoint, and leader election for scheduler failover. If scheduler gets failed, then who will be the leader? So now follow-up question 8 is incremental crawling. Now what is incremental crawling? See, L4, L5 say only revisit pages that are likely to have changed. Okay, not all the pages from the website, but just the pages which have just recently changed, updated, okay, because the earlier one you have already visited, that's why. L6 will say use signals such as last crawl timestamp, okay. And then HTTP ETag. What is HTTP ETag? HTTP ETag is entity tag, is a unique identifier or a version number assigned to a web page or resource to detect whether it has changed, okay. And then last modified header and historical update frequency. Follow-up question 9 is related to spam detection, okay. L4, L5 will say that filter obvious spam pages before indexing, and L6 will say that combine ML based classifier, okay, link analysis, content quality scoring, domain reputation, and user feedback. Now to reduce spam in the search index. Now follow-up question 10 is related to freshness strategy, okay. So L4, L5 will say that frequently changing pages should be crawled more often, right? And L6 will say adaptive scheduling. So what is adaptive scheduling? See, news site, so every few minutes. Adaptive means it depends, like news site, so yeah, it has to crawl every few minutes, right? But if it is a blog, then daily. If it is a documentation, then weekly is fine. So adaptively you are changing the scheduling, okay. Now allocate crawler budget based on the change frequency. Follow-up question 11 is queue design, okay, how you will design the queue. L4, L5 will say use a distributed priority queue here. L6 will say maintain separate queue, okay, separate queue for separate things. So for example, high priority, so one queue for that, normal priority, then retry priority, retry queue, one queue for that, delayed queue, and dead later queue. This improves reliability and scheduling flexibility. Now follow-up question 12 is related to monitoring. So L4, L5 will say that they will monitor crawl rate, okay, and then failed request and queue size. Now L6 will say monitor across 4 dimensions, okay. First one is infrastructure, crawling, indexing, and business. So what will come in infrastructure? Your CPU, memory, disk, and network. What will come in crawling? So page crawled per second, and then crawl latency, Robot.txt validation, and retry rate. What will come in indexing? So duplicate rate, okay, spam detection rate, and index latency. What will come in business? So freshness score, okay, that is the part of business, search coverage, crawl cost, and indexed page per day. Now follow-up question 13 is cost optimization. So L4, L5 will say that they will compress the stored pages, auto scale worker, and then cache robot.txt. So auto scale workers also, okay, you have multiple workers working for you, you will auto scale, you will increase the number of workers, okay. Now optimize with L6 will say that optimize with incremental crawling first, okay, don't revisit all the pages, just the changed page revisit. Then adaptive crawl frequency. What is adaptive crawl frequency? Automatically adjusted how often a page is crawled based on how frequently it changes. Then spot or preemptible instances, we have seen that, right? If nobody is using those instances, AWS will give you, or any other cloud service will provide you that in the low cost, okay, and whenever someone required it, it will take it also again, okay, and then again the process will resume from where it has stopped, okay, with the new instances whenever it is free. So now compression, deduplication, tiered storage, and then intelligent scheduling, okay. Tiered storage means hot, warm, cold, okay, we have seen that with different cost for each storage. Now follow-up question 14, the last one is AI summarization pipeline, okay. So L4, L5 will say that generate concise summaries before indexing to improve AI powered search responses, okay. So now here you need to talk about AI powered search also, right? So for AI powered search, whenever you're adding that into the index, before that just do the summary, define the summary, okay. So the pipeline will be like this: crawled pages will go to parser, from there it will go to chunking, okay, then LLM summarizer, it will summarize the things, and then fact validation, so it will check whether it is correct or not, and then embedding generator, it will convert that into the embedding, and then search index, okay, because here we are talking about AI search, so embedding definitely will come into the picture. So what parser is doing there, see here you have on the second stage parser is here, right? So the parser reads the downloaded HTML file, okay, remove unnecessary content like scripts and ads, and extracts useful data such as the page title, main text heading, metadata, image, and links. So the AI pipeline should generate summaries, okay, then create embeddings. After that, extract entities, classify topics, and support RAG-based search assistant. So that's it. Thank you.